I think we're live with the recording. So welcome everyone to SQL Friday again. This is number 85. So it's becoming a habit, more or less, to do this on Fridays. Today we have Torsten Strauss with us, who is going to talk about locking, which is a good thing in a transaction manager, and blocking, which is I mean, it's natural that we get blocking, but it can lead to performance issues. So Torsten is going to talk about how to detect locking and blocking, or especially blocking, and things we can do to mitigate performance issues that stems from locking. So I think that was a decent intro to what you're going to talk about. Torsten is a MVP. Data platform MVP from Germany, and it is, I think, the third time Torsten is on SQL Friday. So I'm glad to have you back, Torsten.
Yeah, thanks a lot. So, by the way, just want to confirm you can hear me at least.
I hear you.
So let me share my screen with you.
Absolutely.
And let's hope it works.
It does. Perfect. Marvelous.
That's great. I mean, it's really easy to connect by Teams. So I had already a lot of sessions with other platforms, and sometimes it's really hell just to connect to the platform. Yeah. So, okay, cool. You can see my screen. You can hear what I'm talking about at least. Yeah. So that's cool. Yeah, let me start. So as already mentioned, I think it's the third time now that I was invited, luckily, to present at SQL Friday. And this time I would like to talk a little bit about locking and blocking. Because as already mentioned, locking and blocking is definitely, or can be, a performance bottleneck. I mean, there's nothing we can do. Yeah, I mean, we will see there's even something which we can do against locking. But I mean, locking is a root cause for blocking. Yeah, without having, I would say, incompatible locks, you will never end up in a blocking situation. That means in order to resolve locking and blocking, you have to reduce likelihood that you have a lock. So that is the only possibility to get rid of blocking, right? So, and I'm not, okay, let me first of all give you an idea why SQL Server, and this is not only true for SQL Server, this is common for every RDBMS system, why we need, I would say, locking. So you remember that there is a term which is called ACID, yeah, so atomic, consistency, isolated, durable, and which is related to a transactional database, right? We are talking about transactional databases. That means, in our case, SQL Server have to prevent and also to secure a transaction from a competing transaction. That means when you look about when you think about ACID, so atomic, consistency, and isolated. So we are mainly talking about isolation. Every transaction has to be isolated from each other. Yeah, so that means a transaction which is currently running cannot, or must, the other way around. It cannot interfere with another transaction. Yeah, so, and that is the reason why SQL Server have locks. So we have a lot of locks. We have, for example, the most prominent one, a shared lock. We have an exclusive lock. Yeah, so when we read, we have a shared lock. When we write, we have an exclusive lock. I mean, there are update locks and bike locks, and we have intent shared locks, but this is maybe a little bit too complicated for this. I would say it's not too complicated, but this is not the focus of this session. You just need to understand, so when in our default transaction isolation level, which is on premise read committed, and we will see that this is different in Azure, but let's talk about the on-premise SQL Server installation. So read committed is I would say is based on locking on blocking. So this is a pessimistic concurrency model. That means when someone is reading data from a table and you're trying to update the same record at the same time by another transaction, you have a shared lock which is not compatible with an exclusive lock, and that is why you will see a blocking situation. And again, it is very common that you read data and you write data, you modify data at the same point in time. So how can we resolve the problem? And we will see a lot of different ways to resolve it. And depending on your needs, it is on you to decide which kind of mechanism or technique you will apply in order to reduce locking and blocking. There is no, I would say there is no way I really want to recommend, because this is definitely depending on your workload, right? Because if there is the golden way to resolve locking and blocking, I mean, Microsoft would implement this one, and you have a lock and block free environment, which is not the case. So let me go to the demonstration. So you should see Management Studio now. So yes, let me start with one example of how to resolve locking. So, and I like this approach because I'm talking about partitioning, and partitioning can resolve locking and blocking, and partitioning also have some performance benefits in terms of reading data and also writing data. So when you have tables, when you have a table with millions of records, it's definitely worth to think about partitioning, right? It's easy to implement. It is not that easy to maintain, but when you have it, you will see a lot of performance gain. So let me create a test database here. So, and I just want to execute the code, and then I will tell you what the code is about to create. So you can see a test database is created. So we have our primary file group here, which have to be there in any case. And then we have, I think 11 or in this case, seven file groups. And we have a physical file which is currently allocated to the logical file group, because a file group is a logical container, and the file name, so the file is a physical file which is currently attached to the file group. Yeah? So very easy. So I will set the recovery model to simple, just in order to avoid that this transaction log becomes full. So when I create a table, so a table which is a very common one, so sales order detail. I think it's a copy from AdventureWorks, but I didn't remember anymore. So, and this is how our database looks like at the moment. So we have our primary file group. This is a physical file, and we have 7 additional file groups with 1 physical file each. Yeah? So that's it. Very easy. And this is just a preparation. So for your reminder, it is possible to create 15,000 petitions for one table or one index, which should be sufficient for almost every scenario, I guess. So let me use the test database here. Just want to make sure that there is no leftover. There's nothing, that's perfectly fine. And I will create a partition function. So when we talk about partitioning, first of all, you have to create a partition function. And when you have a partition function, you can create a so-called partition scheme, because the scheme is based on the partition function. So let me create one. So I do not want to go into detail, because this is very well documented from Microsoft how to create a partition function. So the idea is that I have one partition function, or one, I would say, partition range per physical file. Yeah. So I'm now going to, let me go down. I'm now going to create a partition scheme, and you can see it here. So align the partition scheme with a partition function, yeah, so that every partition have its own physical file. That is the idea. So nothing very complicated. As mentioned, partitioning per definition is not that complicated. Again, maintaining partitions and thinking about partition escalation, and not partition escalation, elimination, that is a little bit more complicated, but this is not the focus of this session. So anyway, so I will create the table another time, but this time you can see the difference. I'm using the partition function to create the partition to create the table. So very easy. So now we can get all metadata information about the table. I'm just joining different DMVs. You can see in my database test, I have a schema DBO, object name, sales order detail. The partition column name is order date. Yeah, not very surprising because you remember how the table is set up. Let me go up a bit. Here, this is my partition key or column. So data type is date, and I have 7 partitions. Yeah, 7 file groups, and I have a description to understand where the partition value, or to which partition the partition value belongs. So currently I have 0 rows in every partition because I didn't insert any records so far. So that's very easy. So let me go down. And by the way, I need to scroll too often. Let me resize it a bit. Okay, perfect. So now I'm going to populate the table. So I will truncate the table. I mean, there's nothing in, but just to make sure that there's no leftover. And here I'm going to insert the records into the partition table. And now I can get the metadata again, just to understand how the current allocation looks like. So same view as before, but this time we can see we have some rows, almost, I would say, a very even distribution apart from the very first one, but apart from this, roughly 10,000 records per partition. That's it. So SQL Server will automatically insert the value based on the partition function into the right partition. That's the idea here. You do not need to worry about this. So this is done automatically for you. Okay, so now I have a table which is partitioned, and now let's start with a blocking situation even. So the default log escalation mode. So whenever you create a table, the default log escalation mode is table. Yeah, so we will see how it behaves. So, but for now, let's keep it in mind. Whenever you create the table, log escalation is set to table. And we will see we have 2 different values here, auto and partition. So for now, I'm just counting the records where order date is less or equal to 2018 April 1st. Okay, so and we have roughly 30,000 records available. So I'm now updating all the records, all 30,000 records with the update statement here in a transaction, in an explicit transaction. And I leave the transaction open. There's no commit, there's no rollback. Can we do this? So, and while the transaction is still open, we can easily get the logs. So we have a request type. This is, 1 second. I need to scroll up a bit. Yes. We have an X log. We should see it somewhere here. Yeah, the request mode is X, exclusive log, which is grant, right? Because there is no concurrent transaction which blocks us from having the exclusive log. That means the entire table is locked, right? So that is what we can see here. So that is because SQL Server have a so-called log escalation. That means when you reach a specific threshold or a specific number of records, which is roughly, the official documentation is something about 5,000 rows. That is not true, but for now, keep it like it is. Say, whenever you update more than 5,000 rows in an object, in a table, SQL Server, it is very likely that SQL Server will escalate the log to the table. That means there is no log on every single record. There is a log instead on the table level. The reason is that every single log allocates 96 bytes in your logging manager. So this is memory. And you already understand the more logs I have, the more memory you will allocate just to log the specific record, which becomes a little bit, I would say, or the other way around, has a big impact on your system because of the memory allocation for sure. And it is also very hard to maintain. So let me execute this statement in another session. So I'm using the same test database as before, and I just want to sum the order quantity from the table which is currently updated in the other session, in the other transaction, which is still open. But this time, I just want to summarize, I just want to sum up the order quantity for the range, yeah, for the records which are currently not affected by the update statement, yeah, in the other transaction. You remember? So let me go up a bit. You can see what I'm here. You can see what I'm doing. I'm updating, yeah, the order quantity for this specific order date. Yeah, but here I want to create a sum for the order quantity for all records which are currently not updated. Yeah. So what we can see is that we are running in a blocking situation, even though we are asking for a complete different date range. Let me go back to this session and execute in another session. And let me ask for the current logging and blocking situation. So this time we can see we have a lot, 305 logs on every single transaction, every single record which we want to read in this transaction. You can see we have one intent and shared log, which is currently waiting. This is the read transaction. So this transaction is currently was trying to read the records from the entire table, and you remember the entire table is currently locked by an exclusive log. Yeah, and that is the reason why we have a blocking situation. Shared log is not compatible with an exclusive log. So how can we resolve this? There is no way to do it. At least not with the current, I would say, table setup. Let me roll back the session. There was a transaction to be precise. And we can see, yeah, this is the sum, the order quantity total for the specific date range. Okay, the log is gone, the exclusive log is gone. So therefore the shared log can be granted. And that is the reason why we can see the sum of order quantity. Perfect. Okay, so what I can do in order to resolve the issue is, first of all, I can disable log escalation. Let me give it a try. I will use the same database as before. And you can see that the table, the log escalation is set to table, which is default. So let me disable the log escalation. So you can see how to do it. Yeah. Alter table, tells order details, set log escalation disabled. So very easy, but again, this is not the standard. And let me check whether this works. Yes, sales order detail, the log escalation is set to disable. So again, I'm asking for the records, which I'm going to update. Same number as before, roughly 30,000 records. And again, I will update all records for the same date range in an open, explicit transaction. So there's no rollback, there's no commit. Transaction is still open. So this time we can see a complete different behavior comparing to the first example. This time we can see that we have more than 30,000 logs, exclusive log to be precise, and all of them are granted. That means by disabling the table log escalation, SQL Server now ask for an exclusive log for every single record. That is the reason why we can see more than 30,000 exclusive logs in our log manager. And again, for every single row, for every single exclusive log, SQL Server now allocates 96 bytes in your log manager. You can already imagine what happens when you disable the log escalation on every single table in your ERP system. This is for sure a memory contention, because the more, I would say, the more modifications you have on your table, the more memory you allocate just for your logging, just for the logging manager. But anyway, this is definitely one way to resolve the problem, because what we can do now is, first of all, I can ask the memory clerk here for the current memory allocation, which is roughly 6.5 megabyte, just for logging 30,000 rows. And when I execute the same select statement in this session, this time I get the result. Why? Very easy. So let me ask SQL Server. One second, I just want to ensure. So this is 81. Yes, 81. Okay, 81. Session ID I cannot foresee. That is the reason why I always have to change it. So we can see that we have 30,000 rows for our exclusive log, and in the other session, 65, this one, where I'm currently reading, I have 9,807 shared logs. But the shared logs, or the records which are currently, I would say, logged by the shared log, these records are not the same which are currently logged by the exclusive log by the update statement, which is currently running in this session. That is the reason why we are not running in a blocking situation. We still have logs, we still have a shared log, we still have exclusive logs, but we do not compete for the same resource, in this case, the record. So that works. Okay. That is one way in order to get rid of blocks, but not get rid of logs. But because a log is always there, in our standard transaction isolation level, which is read committed. Just want to make sure that, okay, perfect. And I just want to make sure that everything works. So let me ask for a tran count. Okay, cool. I'm a little bit in trouble. Okay. So what I can do as an alternative is, when I have a partition table, which I can set the log escalation to auto. You remember we have table, we can disable the entire log escalation, and we have a log escalation which we can set to auto. That means when I have a partition table, SQL Server will automatically escalate the log to the partition instead of the table. You remember the first example, the first code example where SQL Server escalated to the table. This time we will see that SQL Server will escalate to the partition. So let me do this. So log escalation should be set to auto. Perfect. And you remember that I'm going to update a specific date range. It's always the same date range. So I can ask SQL Server by the $partition function, which partitions will be affected. And we can see that we have 4 partitions, which we will, or where SQL Server will escalate the log, but only for these 4 partitions. Okay, let me do this. It's one additional partition, which is partition 5. That is a partition where I want to read all the records in order to create the sum for the order quantity, right? So there is no overlap. Here I'm trying to update the records, and here I'm trying to read the records. So let me execute this example another time. It's always the same statement. We are just changing the log escalation for the specific table. Again, this works. Transaction is still open. It's not closed. So, and this time we can see that we have a different behavior in terms of the logging. So we can see 7 rows, and that is why that is because we have 7 different file groups. Yeah, and you can see that we have the boundary values here, and we are going to update the first 4 partitions. Okay. When I ask this tran logs for the current logs, we can see that we have the hobbit, and the hobbit is in our case a partition. So we have 4 partitions, and additionally, because the last date will not completely span the last partition, we have additionally, I would say, maybe 300 logs, exclusive logs on every single record. That's perfectly fine. So let me go to the other session. And he includes the execution plan here. So first of all, we can see that we are able to get the sum, yeah, for the order quantity. And that is because we can see in the execution plan that, let me go to the properties, the actual partitions which are accessed by the select statement are partitions 5, 6, and 7, which are not the same, which are currently locked by the exclusive log in the other transaction, because these partitions are 1, 2, 3, and 4. So that is one way or another way to resolve locking and blocking by just, I would say, changing the log escalation to auto, but this only works when you have a partition table. And by the way, the good thing about the partition table is not only locking and blocking, it is also about performance, because SQL Server now can eliminate all other partitions, yeah, in our scenario 1 to 4, and therefore the table scan is more effective because SQL Server can completely skip the first 4 partitions and therefore can eliminate the page reads for the first 4 partitions. That is why we will end up with a more, I would say, with a faster table scan in the end, which will also boost the performance. Okay, let me go back. And for sure we can ask for the exclusive log, yeah, so exclusive log on the hobbit. And this is session 65 now. So this is our current locking and blocking situation. So log escalation to partition 5, 6, and 7. That is the reason why we still have logs, but we do not have incompatible logs and therefore no blocking situation, because again, we are not competing for the same resource, in this case, the partition. Yeah, we do not have any overlap. Cool. Let me roll back the transaction. Just want to check that there is no leftover. Crazy. Okay, I hope it works now. Okay, let me do some housekeeping. Let me close this one. Okay, seems that for some reasons I still have an open transaction. Okay, but it is rolled back. Okay, works. Okay, so another example of how to resolve a blocking situation, or another solution, can be that you add an index. So I will give you an example. I just want to create an extended event here. Very easy one. So the extended event which I created is based on the so-called blocked process report. So let me go to the instance setting. So here in the, what is it, advanced, I guess, yes. In the advanced settings, you can see miscellaneous blocked process threshold. So I guess by default it is 0. So I set it to 5. So you can see it here, right? That means SQL Server will now automatically report the blocking and the blocker query when you have a waiting situation caused by the block, which is longer than 5 seconds. So 5 means 5 seconds. So the recommendation from Microsoft is not to reduce the block process threshold, because otherwise it is very likely that you're running in a deadlock situation. So that is a little bit odd, because you want to resolve, or first of all detect and then resolve locking and blocking. And by detecting your locking and blocking situation, you cause a deadlock situation. Yeah. So yeah, do not reduce the blocked, a block threshold or the blocked process threshold to less than 5 seconds. Okay, let me create this one. I think it's already there. Yeah, it's already there. Let me start the session. And let me create a table, a very easy one. So in this case, we have a heap. Table 1, just 2 columns, both of data type integer, and there's no index on top of it. So we have a heap, non-clustered table. So I will insert 2 records here. So that means our table looks like this. 2 columns, 2 records. Very easy. In this session, I update the table. Yeah, so column 1, record 1, will be updated to 3. So that's the idea. And again, I leave the transaction uncommitted. Yeah, it's still open. So we can see from a locking situation that we have our read as a resource type. Again, we have a heap. That is the reason why we do not see a key. So on a record, or on a record level, we either see a read or we will see a key, depending on the table type. Again, for a heap, you will see a read. For a cluster table, you will see a key. So there is no log escalation for sure, because we are just updating one record. Yeah? So you can see it here. Requested mode is X, exclusive, and it is grant. And we have an intent exclusive log on table. On the page, and for sure on the user table as well. Okay, let me execute this statement in another session. So I'm trying to read the table, and to be precise, I want to read the record which is currently not updated by the other transaction. So I'm again in a blocking situation. So let me ask the log manager again for the current blocking situation. So we can see in this session where I'm currently updating the record, nothing changed, but we have another session which is currently trying to read the record, which is session number 85. And we can see that we have a waiting situation. Yeah. So you will see this in this DM OS wait starts as well, or waiting task, or session wait. There are many ways to see the wait. Yeah. But in general, you can see it here already. You have a shared log which is currently waiting for the release of the exclusive log. That's it. Okay, let me roll back. Let me roll back the transaction in this session. So how can we resolve that? First of all, how can we detect that we had a blocking situation? Because it is very unlikely that you will sit in front of your PC and waiting for the blocking situation. As this happens and you cannot foresee it, then you get a call from your user, your database is slow, and you have to resolve it. Yeah? Maybe you already have a good understanding that your main performance issue is that you I would say, frequently run into blocking situation. That is a reason why maybe you already enabled a blocked or blocked process threshold, which we did. So now we can identify the query which was blocked and the blocking query by the extended event. So let me do this. So I need to execute the entire X query here. It's just the X query. So it is in XML format, so therefore I need an X query. So what we can see here is interesting. So first of all, let's compare the time. This was our last locking and blocking problem. And we can see in the extended event caused by the blocked process report that we had several queries, several or maybe the same query, because the same query will report another blocked process when you have another interval of 5 seconds. So that is something you have to keep in mind. When you have, I don't know, 10 records in your block process report, that doesn't automatically mean that you have 10 queries. Instead, you can have one query which blocked for 50 seconds. So 10 times 5 seconds. But anyway, you have all the information to analyze the root cause of your locking situation. So this is what you get, the timestamp. You get another XML format, or format, let's say, which looks like this. It's, I would say, not very easy to read. That is the reason why I have another X query which extract this column, the block process column or content, from the extended event, which you can see here. This is just another X query on top of the block process to get a better view. That is nothing more. So we can see the database ID, the database name. We can see the duration, and you can see so that almost every 5 seconds, you get a new entry in your extended event. You can see the lock mode, shared lock, which is currently blocking the exclusive lock. You can see the transaction ID. That's it. But anyway, so extracting the block process report, we can see the blocker wait time, and we can see the blocked query. So let me copy this. So this is a blocked query. And we can see the blocking query. The host name, we can see the login name, which is very useful. But let me do this. So we can see the blocking query and the blocker query. Okay, something is there. This is a problem because it is a varchar 4000. This is just one part. So normally we should see the update statement here, because this is for sure not the blocking query. It is a batch. So the statement which is currently causing the block is truncated. So that is because I executed the entire batch and not statement by statement. So let me see whether I have a better example here. Here we can see it, I guess, right? No, still not. But anyway, believe me, it is just truncated, because otherwise you should see the update statement here. Okay, so it's very handy. So now you have an idea about the blocking and the block query, and now you can think about how to resolve the situation. So first of all, what we can try to do is, and I just want to make sure that this session is rolled back. Let me close this one, because otherwise it becomes a little bit too complicated for me. And roll back another time. Okay, perfect. So what I can do is, you remember the problem that we had an incompatible lock, so our shared lock and the exclusive lock, is because SQL Server had to read the entire table, because we just had a heap without a non-clustered index. So the only reason, the only reason that we have a blocking situation is that SQL Server have to entirely read the table. So how can we mitigate this problem? So we can create a non-clustered index. A non-clustered, or for sure we can, a non-clustered index for now. On the table, on column 2, include column 1, which is in our case nothing else than a clustered index. So because on the leaf of the non-clustered index, column 1 and column 2 is included in the navigation. So in the balance structure of the index, we have column 2 as a navigation index key column. That's all. So let me update the row another time. Same value as before. Transaction is still open. Let me go down for the current situation. So this time we can see that there is a read which is currently locked by an exclusive lock. And I will execute this statement in another session as before. And this time it works. The reason is, when you see the execution plan, now I have an index seek on a specific key, and the key in this example is 2. Here we are trying to update the key 1. That means, let me try to get the blocking situation, so that we can see we have a different key here. This is a key, E7, right? And we have another one, which is B04. So you can see already, these are different keys. And therefore, we can grant, or SQL Server can grant the shared lock on this key. And we have an exclusive lock on the other key. That means there is no overlap. Because we do not have an overlap, we are not running in a blocking situation. We still have a locking situation, but not a blocking problem. Okay, let me go down. And for sure, there is an undocumented function which is called logres. And there's another undocumented function which is nfs logcracker. And when you combine these undocumented, that is strange. Okay, sorry, I need to replace the resources, because this is something I cannot foresee. Let me go down and replace this one. Here we go. This is my first key. There's a lot of spaces. And this is a second key. Yeah, now it should work. Okay. So we can see now the translation of the log resource. This is our log resource, and we can see both slots. A slot is comparable to a record. Both of them are located on the same page. This is a page ID. Both of them are similar. But the first key is on slot 0. The second key is on slot 1. And that is the reason, again, we do not have an overlap. Therefore, we can update the one record, and at the same time, we can read another record even in the same page or from the same page. Roll back this one. Okay, let me do some housekeeping. Deadlock is something I do not want to cover, but I will upload the example.
Will you? There is a question in the chat, which I was started to answer it by, and the question is, 5 seconds is quite a long time in a busy transaction system for a block process. So I started looking at the configuration block process threshold, where the lowest possible value is 5. So it's not possible to set that to anything lower. Is there another method for catching block processes which have a are shorter than 5 seconds, so to say?
Understand the question, and honestly, I was asking myself the same question. I'm not aware about another way in order to capture the locking blocking situation by an extended event, because the extended event is based on the block process threshold. And again, the minimum or the minimum recommended value is 5, because otherwise, again, it is very likely that you're running in a deadlock scenario. And I fully agree to the statement that 5 seconds for an OLTP system is already long. It's not that easy. It's not that easy to detect a locking blocking situation. I would say from the past, right? You can definitely identify locking and blocking situation on spot, but not, you had a locking blocking situation in the last 24 hours and you want to figure out what is a locking and blocking query. I would say, first of all, start with 5 seconds, because it is very likely that the query which is a locking and blocking takes the lock longer than 5 seconds. I know this is not true in any case, but I do not see any other way in order to resolve or to detect a blocking situation.
On the other hand, I think, if it's a busy transaction system, once you get blocking, which is 1 second, it's pretty immediately going to be more than 1 second, and you're going to get timeouts, because there will be a chain of transactions.
There will be a chain. You are absolutely right.
Thing, so.
Yes, you're right, and that is also something. Thanks a lot for the hint, because you are absolutely right. The problem, the examples which I shared with you, this is my system isn't busy, so I have a test database with just 2 sessions. This is, I would say, nothing which you will see in an OLTP system. Very likely you will see thousands of requests. And you're right, because we have a locking and blocking situation for 2 queries, it is very likely that there will be a chain of locking and blocking situations, because when one query blocks, I don't know, a specific resource, and the other transaction asks for the same resource, we already understand that we are running in a locking blocking situation. But now we are in trouble, because the query which is currently waiting for the compatible lock also cause another blocking situation for another query which likes to acquire the same, or which acquires a lock on the same resource where the other query is currently waiting on. So that is why you will see very likely a chain, and therefore I think you will see also very likely a locking blocking situation in your blocked, block threshold process report, because of this.
And if I may add as well, sometimes when I see or hear people talk about partitioning, they present fast partition switching, and they say it's always a millisecond procedure. But in a business system, if you do any partition operation, that means you're going to require a schema stability. That lock in itself is really quick, because you acquire it and you switch the partition, and then it's done. But if that schema stability has to wait for anything, that means there's going to be a queue behind it with just shared lock, any locks. So no one can do anything until all the exclusive locks and shared locks are done with whatever they're doing. So very often, if we know this, we know this. It's same with an online index rebuild. It has to end with switching the existing index with a new one that we built on the side. So
that's true.
So we can sometimes see that in graphs, a glitch. It's normally a second or 2, but it's good to know that it can happen. It can cause some timeouts in the application, even though the lock itself is really, really short.
Yeah, that's true. This is also about thinking about the right entity relationship model and the features you're going to use before even you start creating your database, right? So, so what I want to present in order to resolve locking and blocking situation so we have two at least there are many other ways, but there are two other ways. So first of all, we have something which is called optimistic concurrency, which completely eliminates the likelihood that a writer blocks a reader and the reader blocks a writer. Yeah. So that is maybe one way, and that is, from my understanding, Microsoft decided to replace the read committed snapshot, the read committed transaction isolation level, yeah, on premise in Azure by read committed snapshot isolation. So this is optimistic concurrency. I mean, yeah, it's not bad, but I'm pretty sure I had another session about optimistic concurrency even on SQL Friday, I think maybe half of a year ago or whatever. So it's not for free. Yeah, I mean, it's always finding the right balance, yeah, between performance, impact, yeah, and yeah, I mean, the wait time for an incompatible log, because this is always, there is no way I can recommend without knowing the workload and understanding and analyzing the workload. Yeah, it's very hard to, yeah, I would say to decide already upfront. Yeah. Okay, but let me try to continue and let me try to explain optimistic concurrency, because this is definitely an alternative approach, right? So what I will do is I will create the same blocked, I cannot remember the word, blocked process report another time. It's just the same extended event. And I start this one. So now I create the same table as before. Yeah, perfect. And I set a log on the table. So again, when I run this query in another session, okay, logging, blocking, right? We have an exclusive log. We have a shared log, which is not compatible. Here, no rollback is required, to be honest. But here, this is a rollback. Okay, now, hopefully it was 5 seconds. Maybe I was a little bit too fast, but let's see whether the extended event was able to capture the logging blocking situation. Let me scroll down. No, okay, but believe me, you will see. I do not want to repeat this because I'm a little bit not running out of time, but okay. I mean, I can repeat the same, then I need to wait for 5 seconds, but this is an example which definitely also, I would say, explains the question about, yeah, can we capture queries which are not waiting more than 5 seconds on an incompatible log? That was one example, right? It was maybe 3 seconds. So therefore, the extended event wasn't able to capture the blocking logging situation, right? So anyway, what I can do is the following. I can create the same table another time, insert the same records another time. And Magnus, can you do me a favor? Can you go on mute? I think it's still you, right? I have some background noise here.
Yes.
Yeah, thanks a lot. So let me reset the wait stats. And again, I will set a log on the table, yeah, same scenario as before. And when I now execute the statement in another session, okay, we have an exclusive log, shared log, logging, blocking situation, not compatible. Okay, that's fine. We will wait forever, by the way. I mean, there are hints, yeah, so that you can tell the query to stop when you, I don't know, will wait longer than, I don't know, maybe 10 seconds or whatever. It will be automatically stopped. But anyway, when I now identify the logs, so we have a shared log on session 81, an exclusive log, and on 85, we will see the incompatible shared log. What I can do now, because I'm currently in a logging blocking situation, I can ask this DMO the waiting tasks. Yeah, so, and we can ask for LCK, M, and everything with regards to shared log, exclusive log, intent, shared log, and so forth. And we can see that currently we are waiting. You can see the wait duration is increasing over time, right? This is the wait time the session 85, yeah, will wait for the compatible log. So when you do your analysis, in order to understand whether you have a logging and blocking problem on your system, it is definitely worth, let me do this, to ask your wait, DMO is wait stats. Yeah. So, and here we can see by chance our logging blocking wait time. So, and we can see here, for example, yeah, let me scroll down where wait type like LCKM, whatever. So currently there's nothing in, right? Because the wait statistics, so first of all, I resetted the wait statistics, and the wait statistics are just updated for a locking blocking problem when the transaction is committed or rolled back. So that means even currently I'm waiting, so you can see it here. Yeah, it's increasing over time. I cannot see any increase in DMO's wait stats, but we will see this as far as I commit or roll back the transaction. So that is another way in order to see whether you have a current waiting issue. So yes, okay. So let me roll back the transaction. Is there another no, there's no transaction open. So, and this time, when I ask SQL Server for my wait stats, which are aggregated since SQL Server started, we can see we have an issue with a blocking problem because the intended shared log was waiting for an incompatible log, but I cannot see the blocking and I cannot see the blocker query. I just get an impression about how long your ERP system is waiting for an incompatible log. And when I can see a high number, this is very likely that you have to resolve this problem because this will become your bottleneck. So what we can do now is we can enable read committed snapshot isolation, by alter database, current or name of the database, set read committed snapshot isolation on. So this is something which is very easy to do. So and we can check whether the setting is applied. Read committed snapshot isolation is set to on, to 1. So I will reset the wait statistic as another time and will repeat the same transaction another time. So I'm updating the record, still open. I will run this in another session. It works. So why? Because SQL Server has no, let me go down, no exclusive log on the resource anymore. We do not have a shared log, not an exclusive log. We do not have a shared log on the table anymore because what happens is the following. We can see the page allocation here. So this is page number 129409. Let me copy this one. I mean, there's several ways in order to see the page ID, which is currently used by the update in select statement. But what I can do here is I can dump the page. And when we scroll down, we can see a transaction timestamp and a version pointer. So this record has additional 14 bytes for the so-called version timestamp. So, and the version timestamp is only there when you enable read committed snapshot isolation or you allow the snapshot isolation. So when make it very simple, when you have an optimistic concurrency model in place, because a pessimistic one relies on locking and blocking, whereas optimistic concurrency relies on your tempdb version store. And you can see already that file 1, that is the tempdb. So the tempdb in my case has, I think, 8 files. So, and file 1 currently has another page, 32791, where the former version of the page which I'm currently updating in this session, is sent to. That means the select statement now reads this page and gets the information to get the former but committed version of this page, of this record, from your TempDB. That means every time you update a record in a page, SQL Server will also copy the page to your TempDB version store, which for sure have an impact on your TempDB, also have an impact on your update statement, also have a negative impact on your select statement, because you will be redirected to the TempDB and from the TempDB back to the AdventureWorks 2017 database, to this page. It's something like it's very comparable to a forwarding record or forwarded record, comparing from which perspective you see it, right? So, but it is definitely a way in order to resolve locking and blocking, right? So so we can see the version store. Yeah, so this is dmtran version store. This is nothing else than a specific part of our TempDB. You can see now we have a page. Yeah, and this is the former version of the page. So that's great. Let me try to do something in the very last, in the next 3 minutes, let's say. In memory OLTP. In memory OLTP is really a great feature. I really like it. It has some drawbacks, but in many cases, this is incredibly fast. The architecture of the in-memory OLTP is completely different to the, I would say, traditional disk storage engine, call it like this. So because SQL Server will never ever update the same record in memory OLTP. Let me see whether I have something like here. Yeah, let me. This is great. I like it. I'm pretty sure I can see it. File is there. I'm 100% sure. Query optimizer in memory. Next time. Okay. 1 second. Miscellaneous. So it should be here. 1 second. Okay, why it is not working? I just want to open the file. So this is not true because the file is there. Anyway, so I'm not able to open the picture for whatever reason. Anyway, so the structure of an in-memory OLTP database is completely different. We do not have pages. We only have records. You have to have at least one index per in-memory OLTP table, and the index is nothing else than the link between all the records which belongs to the in-memory OLTP table. So you do not have a page, you do not have an IIM page, you do not have PFS page, you do not have GUM, SGUM, all the overhead is gone. And SQL Server implements in-memory OLTP in a way that it uses so-called multi-version concurrency control. That means when you update a record, and sorry that the picture is not opening. When you update a record, there's one portion of the record which is named begin and end timestamp. So two, let's say, columns, two metadata information. So when you create the record the first time, you get a timestamp, which is nothing else than the internal transaction timestamp. And when you update the same record, you will not update the record. You will create a new record instead, and make the former version of the record invalid. That means when the select statement now reads the record, it will go through the link, through the link chain, and detect and compare the current transaction ID timestamp with a timestamp or between with a timestamp of the begin and the end timestamp. And when the current timestamp is greater than the end timestamp of this record, it will skip this record and will go to the next record, to the new version of the updated record. That means in a memory OLTP architecture or OLTP system, you will never ever update a record. You will not touch the record anymore, just in order to make the record invalid, to say the end timestamp is the time where the record was updated and the new version of the record was created. That means we do not have the need for locking and blocking. We do not have the need for page latches. It's a completely different story, but anyway, worth to mention here. And because of this, we are lock-free. And when we are lock-free, we are block-free. And that is the main advantage of having in-memory OLTP. I will just give you one example, and then I'm done. Oh, yeah, I cannot, for whatever reason, I'm not able to open the picture. So I will create an in-memory OLTP database here very easily. One second. And also create a table. And very, very similar with the traditional disk storage engine, yeah, but you need to have a primary key here because the durability is schema and data. Yeah, otherwise you can also just have a non-primary key, but you always have to have at least one index on your table. Without having an index, you do not have the link, the chain, and therefore you do not have any glue, yeah, for the records. I will insert the same records as before, so it's definitely the same table as before. Yeah, you remember the structure of the table. I will insert records. I will update, also insert or hopefully. Yes, I'm already in a transaction, so I have to go with a repeatable read or whatever. But anyway, let me execute this in another session. Yes, I need to change this, and I can read it. So that means I can update, insert, and whatever I want to do. I can do any modification in a memory OLTP table without having any log. So let me go to the log manager. There's just a schema stability log, which I excluded here. That's all. The schema stability log, as Magnus already mentioned, is there in order to make sure that no one can drop my table when I'm reading or updating the table. But this is a schema stability log on the object, right? Which is not part of the, yeah, I would say data modification of your. I mean, it's the reason you understand. Hopefully, that the schema stability log has to be there in order to avoid that someone will delete your table while you are inserting, updating, or reading data. So that's the main idea of a schema stability log. So that is another example of how to resolve locking and blocking by just switching to in-memory OLTP. That's it for now.
Thank you.
You're welcome.
And I would say in SQL Server 2019, I think it was, we got the ability to enable in-memory, memory optimized tables for some of the metadata, like page allocation and stuff like that, which especially in TempDB, if you have contention with that, just it's a free lunch because it uses very little memory as well.
Yes, so the feature you are talking about is named TempDB. Let me support it here. So memory optimized TempDB metadata. I cannot. Yeah. I need to learn this by heart, but yes, memory optimized TempDB metadata. Yeah, that is maybe worth to have another session because also very interesting to understand what are the benefits here. You are right. I mean, there are just some disadvantages, but I'm pretty sure it is not very likely that yeah, that you cannot use this new feature. But this is only in your TempDB. So the name already, I would say, give you an idea. This is just about the TempDB.
I think there is some breaking change. That's the reason why Microsoft keep it off by default. I think you cannot create a temporary table with cluster index or something like that. That was some kind of breaking change, and then they don't want to risk, and they put it off by default.
Yes, that's true. That's true. Yes, you're right. I mean, there's something about partitioning here. There's something about column store index, which I remember, which is not working very well. And you cannot ask about metadata from the tempdb. Also, I didn't remember anymore. I have to go to the session, but you're absolutely right. There are some disadvantage or breaking changes. Yeah, so therefore you have to be careful. But anyway, I like the feature because it will definitely impact and also improve the performance when you have a tempdb page contention. It is just about page ledges.
Yeah, and I mean, it's if you have tempdb contention, it's usually on some kind of page allocation map. So
yeah.
I mean, at least that's very it's very common that you do have it. So the enabling this, unless of course you have any of the edge cases which causes other things to break if you enable it, but otherwise it's a free lunch because it's so little memory used by just the metadata for tempdb. So
that's true. But again, it will not resolve. I just want to make it clear. I fully understand that I would say the difference here, but the new feature will not release the locking blocking problem in a user database. This is really just about
no,
right?
Yeah, and I think it's good that you mentioned that the quick fix that many people implement or recommend to just enable read committed snapshot, but then you get so much more IO. Both read and write true. IO for anything you need to do. So it's not a free lunch at all.
No, and you have to be very careful because you have to control your tempdb. Yeah, so I would say because you already understand that whenever I modify a record in a user database where I enabled read committed snapshot isolation, the former version of the page will go to the tempdb, and this will even worse when you allow snapshot because there's a different behavior in terms of, if I remember this correctly, the behavior is different in terms of repeatable read. Yeah, so the version has to keep longer in your tempdb. I think when you enable when you allow snapshot, so the difference here is really that you allow snapshot isolation on the statement level, and not I would say for the entire database to replace the transaction isolation level read committed, which is a standard on premise.
I have some more questions in the chat, but unfortunately I don't have the time to shoot them off. So I recommend if anyone has questions that they, I mean, if they are on a general level, I'm sure Torsten will be happy to answer.
Yeah, sure. Just send me an email.
It's not going to be free consulting, but if it has to do with this presentation, I'm sure you can.
Yeah, definitely. Yeah. When it doesn't take ages, to answer the question, I'm more than happy to do this.
Sure. So I need to run off because I have kids to feed and stuff like that. So, but thank you so much, Torsten, for
thank you
being back here.